Algebra 2 Trig. We are now on lesson 26. Oh my goodness. All right, so we are continuing with trig functions. We are talking about angles. But now we're going to get out of a unit circle, meaning the radius is 1. But let's review what we were doing. So let's draw 5 pi over 6. All right, so if you remember that 5 pi over 6 would be 5/6. This is pi, this is 6/6, so we want to be a little shy of that. So this is 5 pi over 6. And 330 degrees, that's going to be almost all the way around. That's going to be 30 degrees shy of being all the way around. So that's going to look like this. I don't know why there. Okay. So all of these we were doing with a circle of radius 1. Okay, so now what happens when we're talking about a radius other than 1? That's what we're looking at today. So let's say we're given the point 512 on the terminal side of an angle theta in standard position. Find the 6 trig functions. So let's map out the point 512. And that would be over a little and up a lot. So I'm just going to guess 512 is about right there. And so we could have some angle here. And we need to know what that is in radians. Okay, so if that is 5/12 or 512, we are going to draw ourselves a little triangle. So let's switch up the colors here. Let's go with the red. And let's draw a right triangle. So let's just really focus on this right triangle. This angle here is theta. And if we went right 5, then that length is 5. And we went up 12, then that length is 12. So now really all we're looking at is a right triangle. And we want to find the 6 trig functions of theta. And so this is just regular old SOHCAHTOA. So really, I could just quit talking here and you could go ahead and finish. But I won't. So how do we find the third side of a right triangle? If it's the hypotenuse there, we're going to do a squared plus b squared equals c squared. So 5 squared plus 12 squared equals x squared. Unless you already know one of your Pythagorean triples, but let's do it anyway. This is 25 plus 144 is x squared. That is 169 is x squared, so x is 13. So the length of this side is 13. And so now we can find all our 6 trig functions. So sine of theta is opposite, which is 12, over hypotenuse, which is 13. So look over here to the right. This is another way that we write these, okay? We have the radius of the circle, that's r. Here's our radius right here. This is r, our radius of our circle. And we got that by doing a squared plus b squared equals c squared. That's just the Pythagorean theorem. That's what we did to get 13. So that's nothing new. That's nothing fancy. This is just a squared plus b squared equals c squared to find the hypotenuse. Okay? And then sine is y over r. Well, we just did that. Y is our 12. R is 13. So this was just opposite over hypotenuse. All right. And then what about cosine of theta? Is going to be adjacent over hypotenuse. Well, our adjacent is 5. Our hypotenuse is 13. And that is x, which was our adjacent, over hypotenuse, which is our cosine. And then we have tangent of theta, which is opposite over adjacent, or y over x in this case, or 12 over 5. And then our other three trig functions are really easy once we have those because they are flipped. So cosecant theta is sine flipped. That's 13 over 12. Secant theta is cosine flipped. That's 13 over 5. Cotangent of theta is tangent flipped, so that's 5 over 12. So that's how we find the 6 trig functions, given a point. All right. Let's do another one because this one's slightly different because it has a negative. Okay, so let's plot the point 8, -6. That would be right 8, down 6. So we'll go about right there. And that would be our radius of our circle. Oh, that was a really poorly drawn line. Let's try that again. Let's try that again. Here would be our radius of a circle. That's not much better. So we're just going to leave it. So we have our x value here, which is 8. And then we went down 6. So that's a -6. -6 is really weird for the side of a triangle, but we need to get our signs on track. So I like to just put -6 there, even though we know the side of a triangle cannot be negative. That's the right angle. That makes the radius of the circle r equals the square root of x squared plus y squared, or just think regular old Pythagorean theorem, no big deal. Or if you know 3, 4, 5 triangles, you would know the answer. So this is -6 squared plus 8 squared equals x squared or r squared or whatever letter you use. So that's 36 plus 64, which is 100. So x is 10. So our radius is 10. It is always positive. R is always positive. So the only thing that can be negative is your x or your y. So then we just continue on with our 6 trig functions, making sure your 6 is always negative. Okay, so we have sine of theta is y over r. And so if you want, you can just write that x is 8, y is -6, and r is 10, and you can use these instead of SOHCAHTOA. So sine is y over r, that's -6 over 10, which reduces to -3/5. And then we have cosine of theta, which is x over r, that's 8 over 10, which is 4/5. And then we have tangent of theta, which is y over x, that's -6 over 8, which is -3/4. And then cosecant of theta, that's sine flipped, that's -5/3. We have secant of theta, which is cosine flipped, so 5/4. And we have tangent of theta, which is, nope, just kidding. We did that already. We have cotangent of theta, which is tangent flipped, which is -4/3. All right, so that's how the negatives work. Here's another way to look at the negatives. Maybe if I can get there. So some people use this, what's that called? All students take calculus. ASTC. All students take calculus. And you do that around the order of the quadrants. 1, 2, 3, 4. All students take calculus. And what that tells you is which trig functions are positive in that quadrant. So in quadrant 1, all are positive. In quadrant 2, S for students, also S for sine. Sine is positive. So if sine is positive, then cosecant is also positive because they're flipped. but cosine is negative. So the other ones are negative. So negative would be cosine and secant and tangent and cotangent. Well, why is that? Well, sine is y over r. So remember that r is always positive. So r is positive. Okay, and x connects to our cosines, and y connects to our sines. Nope, that's backwards. Nope, that's not backwards. Sorry. All right, so in quadrant 2, we would go negative, then positive. So our signs there, let's get another color. Let's go purple. Our signs there would be negative, positive. So everything in the second quadrant will be negative, positive. So cosine will be negative, secant will be negative, tangent will be 1 negative, 1 positive, sine, that's connected to the y value in r, that'll be positive. Okay, I feel like I just made that more confusing. So let's make it less confusing down here on tangent. So all students take, so in quadrant 3, take starts with a T, tangent is positive, cotangent then is also positive. The symbols there are going to be negative, negative. So tangent, which is y over x, will be negative over negative, which is a positive. Everything else will only have one negative, and therefore everything else will be negative. And then if we go to our fourth quadrant, that would be positive, negative. Our coordinate will be positive, negative. So cosine is positive, which means secant is positive. Everything else is negative. Okay, so let's answer a question based on that. In which quadrant would you find an angle theta with cosecant negative? So we're saying cosecant is negative and cotangent is positive. All right, well, cosecant connects to sine. So if cosecant is negative, then sine is negative. And if cotangent is positive, then tangent is positive. So are all students take calculus? So a lot of people just write all students take calculus. And it's which one is positive there. Everything else will be negative. So where is tangent and cotangent positive? That is right here. And so our answer here is quadrant 3. Okay. Hopefully that makes sense. So on your own, here is an example. And the point's -2, -1. That means it's going to be negative, negative. That means it's going to be down in the third quadrant. So go ahead and draw that. Find the 6 trig functions. Go ahead and pause. When you unpause, I will magically give you the answers. All right, so there you go. A couple things. Make sure you simplify. Make sure you rationalize denominator. So sine and cosine both had a root 5 on the bottom, so you need to rationalize that. Another little trick is when you're flipping. So here, when you flipped cosecant and secant, don't flip your final answer for sine, because if you flip the negative root 5 over 5, then you're going to have to rationalize the denominator again. So back it up to here where you had the radical in the denominator so that that flips. So flip the radical so it goes from denominator to numerator, so you don't have to worry about it. You'd get the same answer either way, but it's easier. So there you go. And then you can see in our third quadrant that we are in our third quadrant here, which is all students take calculus, which means tangent is positive. And so tangent is positive and cotangent is positive and everything else is negative. All right, that is all. Have a great day. Pop in to see me in a Google Meet if you need help. See ya.